I'm here with Sarmat Qudri, co-founder and CEO of LastMile AI, an expert on model context protocol and building production AI systems. Sarmat, thank you for joining us today.
Thanks so much for having me, Zoltan. It's very nice to be here.
So I'm very much looking forward to pick your brain about your expertise on MCPs. And I'm sure that all of the students are quite excited about what you can share with us. So let's just start a little bit with your background. Can you share a bit about yourself and your background?
Yeah, I've been working on developer tools pretty much my entire career. I started off at Microsoft, worked on compilers, build systems, IDEs like VS Code, and probably the most relevant part was actually working on language servers from with language server protocol back
Mhm.
in the day. And I'll explain a little bit on how that's related to MCP. And then over the last few years, I also worked at Facebook building some of the ML ops infrastructure, so the Jupyter Notebooks platform, model management and experimentation platforms, kind of the developer tools for ML engineers and data scientists. And then about 2 years ago, what we saw with generative AI is everybody was starting to use ChatGPT, and actually developers were starting to build with AI systems. Was that the people who are actually building AI applications, who we now call AI engineers, they're not the same group of people who were building ML models in the past. Like they're not ML researchers generally, they're not data scientists, they're regular web developers, software engineers, folks like us, who've been kind of on the on the fringes of the ML
Mhm.
space and now are at the forefront of it. And our intuition at Last Mile was what does the developer platform look like for this new, much larger group of people to be able to successfully build AI applications? How do you get them into production? What's those last mile problems that you face in that path to productionizing an AI feature or AI application? And that's really what we've been trying to solve. And so I'm very passionate about developer tools. MCP fits right into that bucket as well, as I'm sure we'll talk about later today. And we're just like a developer tools and a developer first company.
Exciting. Okay, so you very much answered my second question already. So what I wanted to ask is, like from your experience building ML platforms at scale, what were the biggest gaps that you've seen or what you see between research and experimentation and actually production deployment, so putting things into production?
Yeah, I think the simplest way I can answer that is it's never been easier to put up a prototype today. You can vibe code your way to something that works maybe even 50, 60, 70% of the way. And it's really easy to get to very impressive demos. And that's especially true with these AI systems that are increasingly sophisticated and have a lot of like error redundancy kind of built into them because they can reason about what you're trying to say. But the real challenges happen when your brand is on the line, when real dollars are on the
Hmm.
line, when these systems are trying to make decisions on your behalf, take actions on your behalf. And so really the difference between scale versus demo is similar to how it has been always with distributed systems, but with the added expectation of non-deterministic systems that are inherently like the case in AI models and AI
Yeah.
systems, adding an additional layer of complexity. And so a lot of the challenges we see customers face include things like, how do I know if my application is working well or not? And that's such a simple question, but at scale, when it's real users interacting with it, that's deceptively hard. And so there are evals and things like that that, people often talk about. Then there's the question of how do I like systematically give access to AI models, AI systems, to data, to tools, to APIs, and how do I do that in a way where I can kind of control the behavior patterns of these systems? Because otherwise, unbounded, they can have compounding error rates, they can go off the rails, they can do things that weren't intended. Security is another big issue, right? Like,
Yeah.
how do I kind of constrain the security and what are these tools able to accomplish on your behalf? And a lot of these patterns are still emerging, but you can think of them as close siblings of the kind of things that we had to face when we are scaling out distributed systems in the past as well. And so I often try to like look back at what are the parallels to the previous world, like software 2.0, to
Hmm.
kind of
Hmm.
understand where things are headed now.
All right. So I will ask you a few more questions about evals and the security, but just to ensure that that all of the students have context of what you do, there is an open source project called MCP Agent, which became quite popular on GitHub. Can you share a little bit about what MCP Agent is and why you started this project?
Yeah, happy to actually. I'm very passionate about MCP and MCP Agent. So a little bit of background. I mentioned earlier I worked on language servers at Microsoft as well. And really the thing about LSP, language server protocol, is for folks who are not familiar, it's basically the way that IDEs give language features to different programming languages. So if you're coding in Python, you get autocomplete or you get go to definition or find all references. The way that's implemented is based on an implementation of a protocol called language server protocol. And so there's a language server running in your IDE client that basically knows how to do Python, language features. And before LSP, the protocol came about, every different IDE like Eclipse, VS Code, Visual Studio, you name it, had its own esoteric way of enabling language features. And so you can imagine that like a Python language server developer would have to re-implement their capabilities n different times because every IDE has its own unique way of doing it. And so then they couldn't focus on like just one really solid implementation. And so Microsoft created this protocol that standardized all of that. It completely flattened how you enable language features. And today, every major IDE kind of implements LSP. And you can also see how that's revolutionized how you don't even think about language features anymore the same way
Mhm.
people did, 10 years ago. When I was growing up in college, like Notepad++ was a thing. So, there was all these like different IDEs. There are some people at Microsoft who still use Notepad to like code because like IDEs were not giving them as much value, which blew
Wow.
my
Yeah.
mind even then. And so it's like if you think of IDEs as giving like these developers context about their programs, the thing that the intuition I had at the very beginning of this AI revolution was how do you like translate those similar patterns into giving LLMs context about the world around them. And this is before like ChatGPT had plugins or LLMs could make tool calls.
Uh-huh.
But I had this intuition of thinking about like basically connecting LLMs to the world around them. And the world around them includes APIs they can call, data or resources they can interact with or read, and then also like prompts that they can use. And
Uh-huh.
then when the MCP came out towards the end of last year, I was so excited because it was finally the culmination of, aha moment for me that, oh,
Uh-huh.
finally a big AI lab has tried to like actually encode those principles into a protocol. And the only reason this protocol is valuable is in building agents, because what is MCP effectively? And we'll probably talk about this in much more detail in a bit. And I know you've done a great like set of kind of educational content around helping people understand this protocol. But in its fundamental level, it's basically connecting LLMs to the world around them in a systematic way. And the only reason you do that is to build agents, to give these LLMs agency to do actions on your behalf. And so what I built was basically this way of building agents with MCP with the expectation that MCP is going to be a big standard that will take over the world. And this is
Mhm.
before it was popular. There was like a bunch of hackers who were really excited by it, but not many people outside of that. But we were convinced that, it was going to be a big thing. And so how do you build agents in a world where MCP is the de facto standard interaction model? That's really like the essence of MCP agent. And then it gives you a couple of simple patterns for being able to quickly spin up like production grade agents in an easy way and gets like the hard part of connection management of MCP servers and the configuration and all of that kind of like out of the way. So you can just think about building your application and not
Mhm.
about all of those like semantics of MCP specifically. So yeah, in a nutshell, that's what MCP Agent is, and we have a lot more plans for it. But the cool thing is we're building on the base protocol, and the protocol is becoming a standard already within a few short months. So it's very cool to see the growth of the ecosystem.
All right, that's super exciting. And so I've seen one of your talks earlier, and then you said that the project was inspired by Anthropic's blog post. It's a very influential blog post, which is in the course resources for the students, which is called Building Effective Agents. Can you briefly introduce the main concepts presented in this paper and how MCP Agent implements these concepts?
Yeah, that's a great question. So building effective agents, for folks who haven't read it, was a very popular post that Anthropic's engineering team made that basically outlined the patterns for building agents that Anthropic's applied AI team had found really effective in production grade agents. And the essence of the post was that you don't need to like overcomplicate the agent architectures to get along a lot, like pretty far. So the simplest agentic pattern is what they call the augmented LLM, which is basically an LLM that has access to tools and
Mhm.
resources, and you can run it in a loop, and the LLM decides what to do next. Like it might call a tool, it might fetch some data, it might, analyze or reason something, and so that's like the simplest base pattern. And then they outlined a couple of like patterns that are pretty familiar to people who build distributed systems. There is a router pattern where a request comes in and an LLM kind or some kind of like reasoning engine decides which module to route it to. And so then that's basically a router. Then there's a fan out and a fan in one where you give the same request to n different augmented LLMs. They do their thing. They might call their tools, fetch data, reason, whatever, and then they aggregate the responses and produce a single response at the end, which is like a fan out, fan in kind of like pattern that exists for any parallel workflow in distributed systems. Then there's orchestrator where you have a much more arbitrary kind of task that comes in, and there's a planner that first breaks it down into a series of steps. It has sub agents maybe to execute those different subtasks. It parallelizes the workload as it needs, manages. It's almost like a task manager, effectively. And once all the subtasks are done, it will synthesize a response and produce that to the user. And so, really, the insight I had was these are all composable patterns that build from one to the next. And so I just implemented all of them in MCP Agent. So if you use MCP Agent, you can kind of like get all of these patterns that Anthropic outlined for free. And
Mhm.
depending on your use case or how you want to design your agent, you can kind of like use these patterns. But the cool thing is you can compose them together. So you can like have a router that's being used by an orchestrator or some step of the workflow is fanning out and then fanning back in. And it just like works nicely. And it's just programming at that point. There's no fancy primitives around, graphs or like visualizations of it. It's just like writing your application script, similar to how you would for a Streamlit app or any other kind of like, program.
Mhm. All right. So just to make this very specific to ensure everyone understands, can you give a specific pain point which MCP agent solves and pain point that developers face when they would work with Raw MCP versus your framework?
Yeah, that's a really good question. So the thing I would say is MCP is still pretty low level, right? Like at the protocol layer, it has think concepts like tools, resources, prompts. There's auth added being added now as well. There are a few other things like notifications, logging, etc. But you need, in order to build an agent, you need to like use these in systematic ways and in higher order constructs. So I would say it's a very lightweight abstraction. MCP agent is a lightweight abstraction on top of MCP, and so that you can kind of focus on building your agent workflow instead of trying to reason over these low level pieces specifically. So a concrete example is, let's say you want to build like an agent that sources LinkedIn, kind of like you want to run a LinkedIn email campaign or something. And so you maybe use Sales Navigator to find some leads that you want to email, and then you want to export that to Google Sheets. Like a very
Mhm.
simple thing, but maybe you want like the search to be done by an agent. And then at the end, the agent should like export the data to Google Sheets and maybe also notify you on Slack that it's done its job. So that's like you can like already start to think of like the big pieces of the workflow, the steps that it would need to do. But how do you do that with MCP, right? And so MCP you can have a LinkedIn MCP server that can let you interact with Sales Navigator. You could have an MCP server for Google Drive to create and edit sheets. You can have an MCP server for Slack to be able to send and receive messages.
Mm-hmm.
And then you can use MCP Agent to just like chain these servers together. And for each different workflow, you define an agent that does its step and then hands off the task to the next agent in line to do the next step of the workflow and so forth. And so you're able to think about the agent workflow in these higher order ways, and you let the framework just handle the how to interact with MCP servers so you don't have to really like think about it too much. That's really like the big value of MCP Agent is it basically simplifies the agent development aspect of it. The last thing I'll say on that is actually once you have an agent developed, you do need to deploy it somewhere for the agent to execute. And we can talk about this a little bit more in detail, but at a high level, agents are asynchronous workflows, right? So maybe this is a cron job that would run every night where I query Salesforce or LinkedIn to get my Sales Navigator data and then export things to Google Drive. And I have a new sheet that I can look at every morning or something. And so that like, where does the compute of that happen? It's not just running on my laptop. I might want to deploy this into some infrastructure. And so
Yeah.
we think of agents as workflows. And so you can use traditional like workflow orchestration engines to kind of have the execution environment be similar to a distributed systems like data pipeline kind of infrastructure. So an MCP agent already implements temporal for managing your
Mm-hmm.
agent execution and agent orchestration. And you get that for free. You don't have to like really think about it. You can just deploy that into like a cloud environment, and you have an agent that has an HTTP endpoint that you can invoke as a webhook, as a cron job, even within from like another AI system actually. And we can talk about this in much more detail in a bit. But really, like those are things that you need to think about consciously when you're building and then deploying an agent that MCP agent kind of just takes off your plate and handles seamlessly for you.
So that's already a quite impressive set of features. And what you said was that MCP Agent is a lightweight framework. And I think if we ask around and we ask people like, which is a not lightweight framework for AI development, and people will say like LangChain. So what would you say? What's the trade-off in this design philosophy? In which cases should people use MCP Agent and not go for a super major like gigantic framework like LangChain?
Yeah, that's a very important question, and I'll give a quick background. And maybe it's not even about specific frameworks. A lot of the time, the question comes, should I just use the APIs directly from the model providers to build my agent applications from scratch? And really, what people are saying is, what are the value adds that a framework provides to me that I can't do on my own, or that I can't really like handle seamlessly or more simply without all the abstractions that a framework adds in between. And so I'll point to a couple of trends that I've seen in the last couple of months that I think are fundamentally changing how frameworks should be developed. The one is models are getting really good. And so you have reasoning models that are doing things like chain of thought reasoning, kind of the patterns that React had, all of these pieces that initially were done in the framework layer are now being done at the model inference layer. And so you can just call a model and kind of do the reasoning, which was not possible before. And so a model
Mhm.
may take several minutes to respond in a way that was not an interaction model we're used to. So that's a huge thing that's changing in model capabilities. What that means is that there's less burden on the application developer and less burden on the application framework to do these things because you can rely on the model for some of
Nice.
those
Uh-huh.
capabilities. The second thing is MCP. It completely collapses how LLMs get access to tools and resources. And so you don't need those hundreds of data connectors that a framework like LangChain implemented in the past. because each of those is, if it doesn't already, is going to have an MCP server for it. So now
Yeah.
the framework, all it needs to do is connect to MCP servers to kind of get the job done. And so what that both of those things really mean is that the application framework can be basically a very lightweight orchestration library that lets you connect really good models to MCP and build agentic workflows out of that. And so I'm very opinionated about that in terms of keeping MCP agent very lightweight and only doing the things that you can't really like that still take a lot of effort. So the orchestration and deployment aspect is one where that is effort to set up and do right. So that's something that the framework helps you do. Human in the loop is something that's really important. Agents should be able to be paused and resumed, retried if they fail. All of those kind of primitives you can kind of build in, you get for free from MCP agent that otherwise you'd have to like think through yourself. So those are the kind of things that a framework should do. And then beyond that, it should just like get out of the developer's way. It shouldn't have tons of abstractions that hide how the behavior is happening, that like kind of limit the developer's control over this. And then the last thing I'll say is, because of LLMs, vibe coding, and all of this, it's never been code generation is no longer the hard part. So
Hmm.
developers are able to build applications very quickly now. And so the framework, like even application frameworks should be LLM optimized and not just human developer optimized. So you can build more quickly with LLMs because that's how we're building software now.
Uh-huh.
So those are the principles I think about when I think of like what a framework like MCP Agent should provide to a developer and to a developer empowered with LLMs for vibe coding versus some of the V1 frameworks, AI frameworks that came in the past before these trends became a thing.
Uh-huh. Okay, yeah, this makes complete sense. And what you're saying is that so MCP Agent is a lightweight framework, but there is an extra feature that you mentioned and also write about in the doc that MCP Agent can be used as an MCP server, right? Can you
Yes.
share a little bit about this functionality and maybe give us an example of where this can be useful?
Absolutely. So this is a little bit of a trippy thing, like a little meta. So let me try to break it down a little bit more. Today, if you think of how you use MCP servers, let's say I connect it to Claude Code, like a Gmail server or LinkedIn server or something like that. Then Claude Code gets access to the tools implemented by that server. And then I give an instruction, like I prompt Claude, and it figures out like how to use the tools. So really the agent in this case is the Claude Code application, the client side. So what I'm trying to say is so far agentic behavior with MCP has been the client applications that implement MCP. So that's Cursor, that's Claude, that's VS Code, all of the agent modes that are built into those applications. What we're proposing is an extension of that, which is a new agent pattern where you actually expose the agent as an MCP server itself. So let's say I built this LinkedIn to Google Sheets kind of like exporter agent, and I want to use this agent both from like, I trigger it through an HTTP endpoint, but maybe I also want to like just prompt my Claude code instance to run this workflow. It's
Hmm.
how would I do
Hmm.
that today, right? What I know for sure is that MCP, because it's becoming a standard, more and more client applications are MCP clients. And so the way to connect over MCP to MCP clients is by exposing things as MCP servers. And so what we enable for free in MCP Agent is this idea that you can wrap your agent as an MCP server itself. And so then you can have this agent be available in any MCP client. So you can have it be in like Claude and Cursor and VS Code and maybe in the future Google Sheets or any other like line of business application that becomes an MCP client. And then you have this separation where you define your agent, you have your agent logic and agent workflow encapsulated as an MCP agent, and then you expose it as a server, which then makes it available in any MCP compatible client. And really, like that, I think is a huge thing because then you can actually think of multi-agent workflows all happening over model
Hmm.
context protocol because this agent may be calling other MCP servers, but those servers may be agents themselves, and that's where it gets really meta because you have this
Yeah,
network
yeah.
proliferation of agents that are able to communicate with each other over MCP via tool calling. And so that's really cool. I think the possibilities are really unlimited with that kind of perspective. And there's a couple of other like protocols out there, and people are still thinking about agent-to-agent communication in different ways. But I actually am of the opinion that you can do a lot of that on MCP itself, even as it exists today. And the protocol is evolving pretty quickly to enable even more agent interactions right through MCP itself.
I love this idea. I think that's such an original and great idea. Um, Let me drill down a bit on that because one thing that you mentioned is that you might have multiple MCPs connected to an MCP client, right? And now you talked about it in that context, MCP agent being an MCP. And what I see is that what students struggle with is what happens if you plug in or connect multiple MCPs, let's say 10 MCPs into an MCP client? How can you ensure that you end up with a robust tool calling environment or robust tool calling patterns? Is there something you can share about that from your industry experience? Like what patterns consistently lead to reliable agent behavior when you have a number of MCPs connected to a client?
That's a really, really important thing, actually. So thank you for bringing that up. I'll actually break it down very concretely. What we have found is LLMs do start struggling when you give them more than 30 plus tools to choose from. And so
Mhm.
that may be a limitation that slowly goes away, but even so, you should really think consciously about at every step of an agent workflow, what are the relevant tools that the agent should have access to do its job? And so one of the things that the way we've solved that in MCP Agent is every agent you can actually filter which servers it should have access to. Because let's say like the LinkedIn server agent should maybe only have access to the LinkedIn server. It doesn't need access to the Slack server or something like that. And so that's one really important thing of breaking down your workflow into a set of sub steps where each step you kind of define what are the capabilities that that agent needs access to, and that's an automatic filtering that you apply there. The second thing that you can do, which is a little bit more sophisticated, we're adding this soon, is dynamic filtering. So at every step of the agent workflow, think of it almost like RAG, but where you can like take an embedding of like the conversation or the history of interactions so far, and you take an embedding of all each of the tools that are exposed by the MCP servers, and you basically find the top 20 or 30 tools that are closely
Yes.
aligned,
Mhm.
and you can just add those to that LLM's context so that at every step in the workflow, you're only giving an LLM like 30 choices or something to pick from. And so there are a couple of MCP servers that are already like really large that have many, many tools, and they really do start struggling in production environments unless you implement some kind of filtering yourself. The filtering can be done statically as well if you're really confident of like these are the only tools that you could like this agent needs from this server. But I think you're totally right that as MCP adoption continues to grow and as you have more production grade servers, like these web services, Google Drive, for example, if you look at its API spec, it's hundreds of APIs. And so if there's an MCP server for that, that's going to be really hard to reason about. You can't give an
Mhm.
LLM access to every single API that Google Drive or some like massive like web service exposes. It'll need to be a little bit more thought through than that. So that's like the most concrete thing I would recommend is just limit the number of tools that an LLM has access to at any given time, and that'll get you like a long way.
Thanks. And you mentioned here briefly security. Can you share your thoughts on security? Because now in the news we had like poisoning attacks, and there was an incident with GitHub. And what's your take on that? What's the status of MCP security, and where is it heading?
It's a very important question, and we get this question a lot when we talk to enterprises and enterprise customers looking to adopt MCP. So there are a couple of things. One is this model context protocol spec is unlike other protocols, actually pretty rapidly evolving. And so that's a good thing because there are a couple of these really important things that we need to figure out as an AI community. The good news is there's already an auth spec that is part of the latest versions of the protocol, and it basically enables authentication over OAuth, similar to how IDPs and authentication servers work in distributed systems world before MCP. So it's very consistent with patterns that security practices that developers are already familiar with. At the same time, you mentioned prompt injection. There are a couple of other ways that you can still jailbreak or hack through these AI systems, and those problems have not gone away. We've carried them forward from, those prompt injection attacks were always a thing with LLMs, and we need to protect against them, but it's not an MCP specific problem. What I would recommend folks think about is what are the things that MCP specifically needs to be protected against, and what are the things that like your AI application, with or without MCP, has a
Hmm.
threat model risk to that you need to think through in general, and kind of separate those out because it's otherwise it becomes very difficult to kind of like make forward progress. One concrete thing again I'll suggest on this is we've seen patterns emerge for sending over auth tokens alongside requests to agents.
Yeah.
And think of these tokens as like scopes that give them access to IAM permissions or kind of credentials that the agent needs. And the agent should never be able to like do more than what that token allows it to do. This is standard practice. And like I worked
Yeah.
on Windows back at Microsoft. You pass through credentials that like through tokens, and there's this SID, security ID, that kind of like manages what that process has access to performing, and it's designed in such a way that you can never like get more permission than what that ID gives you. Similarly, at Facebook, there is this concept of like a viewer context, which is basically every object is protected by this viewer context object, which basically controls what data is available at that point in time. So by design, you can kind of prevent data that may be belonging to another user that you shouldn't have access to from ever even being possible to be queried. Similarly, I think agents are going to need that same kind of scoping mechanism because agents are acting on your behalf. And let's say like you and I are collaborating with the same agent, but when I invoke the agent, there should be a Sarmad like token that the agent receives. And when Zoltan interacts with it, there's a Zoltan token that it receives. And that
Yeah.
should by design prevent it from like you accessing my data or me accessing yours. So I think the good news is that these patterns have existed in the past for other purposes that we can now take and apply it to agents. But there are obviously like other kinds of challenges, like you mentioned, prompt injection, and there are many others that we also need to think through because the dangers could be higher when an actor is acting on our behalf.
Yeah. Okay, that's very insightful. So you're saying that basically everyone should follow standard industry practices because many of these problems have been already solved in other frameworks, and some of them are now solved with MCP, like OAuth. If I want to set up a production MCP and I want to implement, let's say, rate limiting, do you have a standard framework you would use, let's say, for a Python-based MCP to integrate my MCP server with?
So you can do parts of that with MCP Agent already, actually. One of the
Oh,
things I
okay.
always recommend folks is there's obviously like token counting is an important thing. Just for cost purposes, you may want to like limit the amount of tokens an agent workflow consumes to some max level, after which you cancel the workflow, for example, or you request the user like, is it okay to continue going? Then there is things like max turns is another way that I've seen it, where you can kind of like see how many loops an LLM can run in
Yeah.
until it accomplishes the task, which is a very crude but effective way of kind of limiting a Cambrian explosion of turns where an agent may go off the rails and continue going forever or
Yeah.
something.
Yeah.
Then there's prompt caching, which is also pretty important. That's turned on by default for the model providers that support it, which I
Hmm.
think is pretty
Yeah.
critical as well for agent workflows. I think the answer actually lies in a combination of all of these. I would start simple. I would start with like max turns being set to some a definite number that's less than infinity, and then there should be something that like counts tokens, which MCP Agent and other things provide. And then I think you can get into rate limiting and some of the more sophisticated approaches from there. Rate limiting in general for, I would say, like MCP servers are web servers. And so if you're a server developer, you should definitely like set up your system in such a way that it wouldn't fall over from DDoS attacks or from high request rates or things like that. But then if you're an agent developer, you also want to be cognizant of like not spamming the GitHub MCP server because that's going to get you rate limited the same way the GitHub API gets rate limited.
Yeah. Yeah.
And so you just need to think about those things a little bit. The same, but the good news, my consistent message is the good news is it is consistent with how you've had to think about those for standard web development. It's not fundamentally new, except that there is a reasoning engine now in your program that's able to like dynamically decide if it wants to make an API call, if it wants to like fetch data, and then you just want to give it some controls on like, hey, don't, spam this system, or don't go crazy out of turn or on some wrong direction that
Yeah.
leads it down a rabbit hole.
Okay. Okay. It all makes sense. So basically the same. We already have the answers for most of these problems. There is one thing you mentioned. It's the token efficiency. Can you maybe share some of your recommendations on how to what strategies have you found for managing token usage? I'm not sure if that's like a question that's tightly put to MCPs or just LLMs in
Yeah.
general, but what would you suggest for people
I,
implementing
it's
MCPs?
really a really, really important thing to think about because any production grade agent workflow will run into the ceiling of context windows if you try to stuff everything into a single LLM call. And so the biggest thing I'd actually recommend is breaking down your agent workflow or your application into sub steps, and each of them is its own LLM invocation. There's prompt caching enabled so that you should ideally be able to, have token efficiency through the model providers provided prompt caching. But even so, like if you limit specific workflow steps where a subtask or a sub agent is just responsible for a discrete part of the pipeline, then what it has to do is already limited. And so then you can like have much more token efficiency in aggregate because there's no single LLM call that's getting tons of context and you're not overwhelming each LLM call. And the other nice thing about this is not just efficiency perspective, but also performance improves because you're not confusing the LLM with a lot of complexity. You're consciously thinking about what do I want in this step for an LLM to be able to do. And then you're just asking it usually to do like one or two things at that step. And a concrete
Mhm.
example would be like maybe
Mm.
you're asking the LLM to fetch a data from a website, and that's all that substep does. And then maybe summarizing that data is a next LLM's job and
Mhm.
so
Mhm.
forth. And that way, like the context that's being retrieved or what each LLM is trying to do is kind of like constrained to its job, basically.
Okay. Um, Thanks. Another topic that you already brought up at the beginning is like, let's assume now we talked through all of that, like how to create an LLM, how to create an MCP, how to put it in a context where it can work reliably. So what happens when I want to evaluate my MCPs? I think at this point in the course, students don't have too much context about how auto eval works, and that's also
Yeah.
a service that you provide with LastMile, and like the general auto evaluation philosophy. Can you share a little bit with about like what that is? What are the best practices? Maybe what are the best metrics, and how can you use LastMile or MCP Agent
Yeah.
for that?
Yeah, that's a really important question and something that a lot of customers are starting to ask us as well as more MCPs go to production. The big question is this a good MCP? And even for like an agent developer, there's so many MCPs out there. So how do you like know if this MCP is good or not? You're either trusting that the provider of that service did a good job, or you're like maybe doing some rudimentary tests. So suffice it to say, evals for MCPs, really, really important kind of subject. Um, what I'll actually describe, we're actually launching an open source project around this called MCP Eval very soon. So would love to share that more. But the essence of it that I would say is the way you evaluate an MCP server is the only reason to build an MCP server is to use it in an agentic workflow. So to evaluate an MCP server, you actually connect it to an agent and ask the agent to perform some tasks, and then see
Mhm.
if if the server does a good job. And by that what I mean is, let's say that the agent tries to call a tool on the server. Was that the right tool to call? Did the tool call succeed? Did it fail? Was the steps that the agent went through efficient at achieving the objective? Was the objective achieved or not? And so you can already think of this as almost like PyTest style integration tests,
Yeah,
where
yeah.
each test is like an agent objective that you're giving it, and you're connecting it to an MCP server, and then you're collecting metrics like tool call coverage, tool call success, objective success, agent reasoning efficiency, planning efficiency, etc. And then you have a test report at the end, which is basically not just the agent's test report, but actually your server's test report. And once you
Uh-huh.
have these metrics, the really cool thing is you can actually use them to optimize your MCP server. And if you think about like what an MCP server is, it's a collection of tools, and maybe resources are exposed as well. And each of the doc strings for these tools are like prompts for the LLM. Like you're
Wow. Yeah.
describing what these tools are supposed to do, how to use them, all of that. And so you can actually optimize the prompts in your MCP server if you had a test suite of data and metrics as that to use as your optimization function. That's a whole other subject, but that's
Yeah.
like
Yeah.
what we're doing in MCP Eval is enabling like a PyTest extension module to be able to write MCP evals using MCP agent actually, because the agent that you use to connect to the server is an MCP agent. So that's the cool part of like using our existing project to build this like more interesting like evaluation suite. The other thing that you mentioned, auto eval, that's actually a product that we've had for a while now, which is a fine tuning and inference service for creating custom evaluation models. And so what we do is we have these small language models. These are 400 million parameter BERT-based models, and we're able to like teach them through fine tuning your eval criteria. And so you can get a very specific custom kind of evaluation criteria if you care about a specific kind of metric. The example is a couple of customers of ours. They really care about brand tone. They want to like make sure that the LLM agent is answering
Hmm.
questions for their customers in adherence to their marketing guidelines, etc. How do you like evaluate that, right? So we have evaluator models that have been fine-tuned to learn that criteria through good and bad examples. And then you can basically like have a score that you get on how adherent the response of a model is to brand tone. And that's just a completely custom metric, which is kind of cool. But you can think of many other metrics that can exist. There are very serious ones as well, where like there is a company that has a nuclear division, and they don't want to like have any questions that answer anything about nuclear for like from their chatbot or anything. And so
Uh-huh.
they've
Yeah.
trained like a classifier model using auto eval to be able to like prevent that from happening. And so that's pretty cool, right?
Wow.
Like these models,
Yeah.
because they're small, they can be used at runtime because they take only 300 milliseconds per inference request. So you can actually use them as guardrails as well as evals. And so you can catch these things before they hit an actual user, which is kind of cool to see. So that's like actually an enterprise grade platform that we've already had. And now what we're working on is kind of tying all of that back through this build, test, and deploy phase of the agent development ecosystem so that it's like a one consistent product suite.
That's super exciting, and I can't wait to see it on GitHub.
Yeah.
Um, and here is another thing. When it comes to evaluations, what what again students run into is that they usually find it hard debugging MCPs. So when you have, again, a bunch of MCPs connected to an MCP client, you execute some kind of a query, and then something goes wrong, then they might find it hard to like figure it out from the logs how to what specifically went wrong. Do you have, from your experience, what are the patterns that are effective for tracing these issues when it comes to MCP servers, LLM calls, or any external API interaction?
Yeah, I think I would recommend doing the basics right first. So standard like open telemetry style tracing should be a de facto standard for any application, especially an AI application, and being able to like trace the individual steps so you can kind of at least have observability over the call stack of how an input turned into a response from an LLM system. Because oftentimes these systems are no longer just like you call an LLM and you get a response and you return that to the user. They're complex multi-step pipelines and workflows. And so effectively they're distributed systems. So that's like
Yeah.
really important, I think, to just have off the bat. And then the question is like, okay, let's say that like the response was incorrect or bad in some category that you care about. How do you debug what went wrong in that call stack?
Yeah.
And what we recommend in that case is actually it's laborious, but it's actually helpful to think about those sub steps as individual kind of steps in the workflow that you can have eval metrics for as well. And so not only
Okay.
should you have end-to-end metrics, but you can actually have sub metrics within that workflow. An example is like planning quality is really important. So let's say that like an agent, you give an agent an arbitrary task, it has to create a plan and then execute on the plan. The plan quality really matters on what the end result is going to be. And so having a metric for the plan quality is, and that could be an LLM judge metric even, you give it to a reasoning LLM, is pretty important. Another one is tool call correctness or efficiency. Sometimes what we see is like an LLM tried to make a tool call, it failed, the tool call failed, and then instead of either retrying or like returning the error to the user, it just hallucinates something and from its own like understanding of the world and returns a response. And unless you kind of like catch that as an error, it's really hard to know that that happened. And then that might introduce a
Yeah.
hallucination at the end that is either subtle or hard to track or hard to debug why that what went wrong. So having these metrics, and that's like a simple metric, you just have to like check if tool calls succeeded or failed. And
Mm-hmm.
you can
Mm-hmm.
use those as like ways of at least understanding what part of where in your system did things go wrong that led to downstream issues. So I would recommend again starting simple, get tracing set up. Then next step is figuring out like metrics that you can introduce at each sub step, and then like going from there until you feel like you're able to confidently iterate on your application. It requires good engineering practices. That's
Yeah.
the
Yeah.
bottom line.
Okay, so we you very much covered what happens if you use a bunch of LLMs and you want to kind of productionize it with heavy
Yeah.
evaluation and debugging and tracing. Now, what happens if I want to implement my own MCP? What are those architecture choices that I should make if I want to take it beyond the sandbox and make a a scalable, robust, secure, reliable MCP that I can release?
That's a really important thing actually, because I think the community is just on the verge of that inflection point of going from MCP as a interesting thing to MCP as a robust production grade kind of thing. You mentioned GitHub earlier, right? Like we
Yeah.
already saw that there are some security vulnerabilities found even in like a very good engineering culture tech companies implementation. And so I think there are like learning kind of things that need to happen before we get to like robust practices. But at the end of the day, I think like auth really matters. Like make sure you implement the auth spec for MCP for user authentication. I would argue like HTTP endpoints, like streamable HTTP servers, is
Yeah.
gonna be the predominant way that MCP really takes off. So investing in that is important. And that the good news is with that, you also get like the expectations of how a web service generally operates because MCP servers are still web services at the end of the day for streamable HTTP endpoints. And then I think like really thinking about like agent authorization and authentication is important. So there's a new draft of in the spec at MCP called elicitation. And what that means is human in the loop style workflows. So it basically lets a server request a client for like permissions, for example. And it's like
Yeah.
structured data, so you can kind of structure the permissions how you need. But if you've used Claude Code with MCP, you would find this familiar where, the first time you connect an MCP server to Claude, and it needs to make a tool call, it will actually prompt you in the client to say, allow once, allow always for this
Yeah.
tool
Yeah.
call. And now think of that. That was a client-side implementation that Anthropic team built into the client. But you want to expose that for every kind of like as a server developer, you want to make sure that like that pattern is available to a server to a client that uses the server if the client implements that the elicitations part of the protocol. And so thinking about those things is really important because again, going back to the idea that MCP servers can be agentic themselves. That's the next step that we're headed to because so far the trajectory has been people saw that they had like REST APIs, Open API specs, and they just did a one-to-one conversion of those into MCP tools. But the next
Yeah.
step is these MCP servers should be able to do agentic things, behavior within themselves as well. So then you could expose like even in the GitHub server, maybe there's in the future there's like an analyzer tool that can like analyze your repo for recent like trends or something. I'm just thinking off the top of my head, but like the idea being that then there's an agentic workflow that the server does that isn't just an API call that you make like a REST endpoint. So that's like those are the things I would think about. And the last thing I'll say is and this is actually, Zoltan, I think you're doing a great job of enabling this. Really understanding the MCP spec is important because it's so much more than tools as well. There's resources which are like not as well understood yet. I just mentioned
Yeah.
elicitations, which is a draft. There's also prompts, like a server can expose high quality prompts that are like engineered to work well with this server, and exposing that can
Yeah.
help users get started with the server and use it more effectively than they otherwise could. So I would recommend like server developers to really understand the spec beyond just the tools side of things because there's like a lot of interesting stuff there.
Yeah, exactly. Um, I also saw when I started working with MCPs that tools are kind of easy to understand, but then when it comes to resources, and especially prompts,
Yes,
then you need to find a few good examples so you really grasp like how they can be useful, but they are super important.
absolutely.
So yeah, thanks, Armad. Maybe just a few final questions. Um, What's your take on the future of MCP? So where is this ecosystem heading? What standards are missing? What's coming? What would you expect in the next few years?
Oh, I think one of the really surprising things, even for me, I got started on MCP pretty early, but even for me, it's kind of amazing to see how quickly it's gained adoption. So it's had like product market fit in some way where clearly like the industry really needed a standard way of having LLMs interact with tools and data and prompts and resources and whatnot. And so I think what I foresee is MCP is going to evolve pretty quickly as well to kind of we covered a lot of challenges that you mentioned that you brought up that I think the protocol is going to need to evolve to kind of solve for. So I expect MCP itself to be a living, breathing organism, not something that's fixed that stays exactly the way it is today. The other thing I foresee is people building more sophisticated agentic experiences as MCP servers and more sophisticated infrastructure that makes it easy to deploy these agents and these servers. Because like I think ultimately the real test and success of the protocol will be if we see agents being more ubiquitous out there. Like that inflection point hasn't quite happened yet. If we think of who are the people building agents, it's still like the startups and the high tech companies and the usual suspects, that you would expect to be at the forefront of this. But can we democratize this even further? That's kind of the mission of my company and that what I want to accomplish. And also, I'm very passionate about like figuring out if MCP can, how MCP can help make that a reality. So that's the one thing I would say. The other one is I'm very convinced that MCP has like critical mass already. So I think we'll see a lot more enterprise adoption in the next year or so from like the large companies that are like startups that are already adopting it all the way to the large Fortune 500 companies that are just starting to like
Mm-hmm.
realize its full potential. And then maybe the last thing I'll add is I think we'll actually get to a much better state of more well-defined patterns of how to build AI applications. Whereas today it still feels a little bit like the Wild West, like you kind of
Yeah, yeah.
pick your religion almost where you're like, okay, I'm gonna like go into this ecosystem and this way of doing things, and maybe I'll get some way there. There's just so much noise in the system to know what are the best practices available. And I think the combination of MCP and really good models and simplified AI frameworks evals, all these together, I think are going to give us really good patterns for how to actually build and deploy production grade applications. And so I'm just hoping for like 100x increase in the agents that I interact with in my daily life because I haven't
Yeah,
seen that yet. I can't wait
yeah,
to
yeah,
like offload stuff to AI systems more and more and trust that they'll do the right thing. So
yeah.
I'm hoping that that's the next 2 years for the ecosystem.
Exciting. And yeah, you're saying that it's today is still kind of the wide west, and also that you got into that quite early. Uh, if if I'm an MCP newbie now and I want to, just kind of understand this whole ecosystem and get started with MCPs, what would be the resources or the communities that you would suggest I join or I read, or what do you suggest your employees when you
Yeah.
onboard them?
Well, first I'll suggest they check out your content. Actually, I think you're doing a great job. And that's like jokes aside, I think that's really important to have like educators out there who are really trying to simplify these really sophisticated patterns that are emerging. The other thing I would say is really do spend a little bit of time understanding the base protocol. I think it's important, especially when there's so much noise in the system. You kind of like may gravitate towards the simple surface level things, but it's important to
Hmm.
just the protocol is not that big. So you can actually just read it or ask Claude to summarize it and try to understand the best kind of like the high level ideas there. And then what I recommend actually people to do is build agents because really that's what is the reason for MCP to exist is to enable agent development. I think there are just so many possibilities, even in my daily workflow. I think in every person I talk to, even at my company elsewhere, they just like have tons of ideas for automation of some kind that LLMs can help them with. And I recommend that they actually build that out either with MCP Agent or just like whatever they want to choose to do that with. But like really try just building that. There's no alternative. There's no shortcut for from like actually trying stuff out and building it yourself to get a
Hmm.
deep
Hmm.
intuition of how it works. And lastly, I would say I think there are all these challenges and problems that we pointed out today, but I would recommend folks not get pessimistic and use that as a reason not to build or not to try things out, because I'm very optimistic and confident that we're actually gonna, like, as an industry, gonna solve and work through these problems because we have no other choice. We have to. And those are all solvable problems because we've solved them before for other kinds of systems. Yeah, just like get started, learn about the intrinsic details, and try to bring the best practices from distributed systems in the past to this world, because that will demystify a lot of things for a lot of folks.
I think that's a great closing sentence. So thanks. This has been extremely useful for me, and I'm sure that it's the same for everyone who is watching this video. So Sarmad, thanks again for joining us today.
Thank you so much for having me, Zoltan. I had a great time. Thank you.